Welcome back to 3 Inquisitive Kids. In this video, we will be learning how to add and subtract unlike fractions. So, you probably already know how to subtract or add like fractions with the same denominator. But what if you're trying to add or subtract unlike fractions? What if the two denominators are different? Well, the only way to subtract or add unlike fractions is to make them into like fractions. And we're going to do that by changing them into their equivalent fraction. There are actually two different procedures for this. And now let's first look at the ECD procedure, which, as you could also say, is easiest common denominator. Using the ECD procedure, we first have to take the bottom numbers of both fractions and make them into whole fractions. What this means is you want to take two denominators and you want to change them into whole fractions. So by that, it means turning this into 6 over 6 and 9 into 9 over 9. So those are whole fractions because they equal one whole. And then it says we have to multiply each whole fraction to the other fraction. So if over here it's 9 over 9, we're going to move this to the other side, which is 4/6. We're going to have to multiply it. So then the equation becomes 9 times 4 over 9 times 6. And then, of course, we have to do the same with the other fraction, which we move this 6 over 6 over to the 5/9, and then we're going to multiply them. So 5 times 6 over 9 times 6. Now, as you might have already seen, what I'm basically doing is just creating the fractions into an equivalent fraction by multiplying both the numerator and the denominator with the same number. But why would we do that, you may ask? Why would we want to make the fractions denominator and numerator larger? Is that going to help us? Well, the point isn't really to make the numerator and the denominator larger. It's to make them like fractions. So, if we have to simplify these fractions, we can get 36 over 54 plus 30 over 54. Since they're now like fractions, we can add them easily by just keeping the denominator the same and adding the numerators together, which would give us 66, because 36 plus 30 equals 66. Now you probably notice that over here we can simplify. The 66 is equal to 6 times 11, while the 54 is equal to 6 times 9. So we can cross these 6's out, and now leaves us with the simplified fraction 11/9. Okay, so now let's try it with the LCD procedure. The LCD procedure says that we need to draw a table of each denominator's multiples. So over here, I'm going to draw a table of the denominator's multiples, the first few multiples. So over here, there's 6 and 9. There's 12 and 18. There's 18 and 27. But wait, over here, you should have noticed something in the table. As you might have seen, in the multiple column of 9, there's an 18. And in the 6's multiple column, there's also an 18. So what does that mean? We already drew a table. We already found the least multiple, which is the multiple of the both numbers that has the least value. And now we have to change the denominators to that multiple. So now it's like fractions. Let's try that. If we want to make 4/6 have a denominator of 18, you should see that we multiplied a 3 from 6 to get to 18. So all we have to do over here, multiply a 3 on the bottom and multiply a 3 on the top. Now we do the same with the 5/9. So we multiplied a 2 to get to 18. So now we have to do it to this 9 over here as a denominator. So that's 9 times 2. And don't forget, we also have to multiply the numerator with the same value. So that's 5 times 2. After this, we simplify, which becomes 12/18, and then 10/18. Now we add. We add the numerators, which is 12 plus 10. That gives us 22. So that's 22 over 18. And now we simplify. Each fraction even numbers, so that means that they can be split into 2 times something. Top is 11 because 12 divided by 2 is 11, and 18 divided by 2 is 9. So we get the same answer. Now, let's start with some other examples. The first problem is 7/5 minus 3/4. Now pause the video if you can solve it by yourself. All done? Now, let's see. First, we can try using the ECD procedure. Just like how we did addition, it's the same for subtraction, except that we subtract the two fractions. We make a whole fraction out of each of the denominators, which would be 4/4 and 5/5. Then we multiply each whole fraction to the other fraction. So now we have 4/4 multiplied with 7/5 minus 4/3 multiplied with 5/5. So now each of these are whole fractions, and these are the original fractions from the problem. Now we simplify. 4 times 4 is 28, and on the bottom we get 4 times 5, which is 20. And 3 times 5 is 15 on the top, and 4 times 5 is 20 on the bottom. So we have made each fraction into its equivalent fraction. So now they're like fractions. We've made subtracting and adding with them much easier. So we leave the denominator the same, and we subtract the numerators. 28 minus 15 is 13, and that is our answer, 13/20. Now, let's try the LCD procedure. First, we take a look at the denominators. That would be 5 and 4. Now we make a table out of it. The 5 is 5, 10, 15, 20, and then the 4 is 8, 12, 16. We still don't have a common multiple yet, so let's keep going. There's 25, and there's 20. Aha! Now we found the common multiple. 20 and 20. Over here on the 5's column, we multiplied a 4 to get to 20. And over here, at the 4's column, we multiplied a 5 to get to the 20. So let's apply that to our problem over here. The first fraction, 7/5. We multiply a 4 on both the numerator and denominator, which would be 7 times 4 over 5 times 4 minus 3 times 5. So over here, we have a 3 times 5 because for the 4, we multiplied a 5 to the 20. At the bottom, again, we have 5 times 4, or 4 times 5. Now we simplify. The first fraction becomes 28 over 20, and the second fraction is 15 over 20. So we leave the denominators the same, and we subtract the numerators, which will be 13. Again, we get the answer, 13/20. Now, the next example. 6/13 plus 4/10. We have the ECD procedure and the LCD procedure. The ECD, we make a whole fraction out of each of the denominators. So that would be 10/10 and 13/13. And then we multiply them to the other fraction. That would become 10/10 multiplied by 6/13 plus, over here I just have to kind of erase this, plus 4/10 times 13/13. We multiply. The 6 times 10 is 60, and on the denominator is 13 times 10, which is 130, plus the 4 times 13 is equal to 52. So that would be 52 over 130. We add the numerators, which would become 112, and then the 130 stays the same. Now remember, you always have to simplify the fraction. No matter what, you always have to simplify. So these are pretty big numbers, but we see that both of them are even. So we know that they can divide into 2's. So we can write the top as 2 times, what's 11? What is 112 divided by 2? 56. And the bottom is 2 times 65. So now we can cross these out, and it leaves us with a 56 over 65. And that is our answer. Now, let's try using the LCD procedure. 10 and 13. Well, before you start doing this, you could see that 13 is a larger number. And we also know that any number that ends with a 0 in the ones place is always a multiple of 10. So all we have to really do is look at the multiples of 13 and try to see which multiple is the first to end with a 0. And that would be our least common multiple. So if you go ahead and do that, you could see that it goes all the way to 130. And 130 divided by 13 equals 10. So that means that we multiplied a 10 to get there. 130 divides into 10 exactly 13 times. So that's why we multiplied a 13 to get from 10 to 130. Now, let's bring what we've done here to the problem. First, 6/13. We multiply both the numerator and denominator by 10. So that would be 6 times 10 over 13 times 10 plus 4 times 13 over 10 times 13. We simplify, which becomes 60 over 130 plus 52 over 130. We add, it becomes 112 over 130 because the denominator stays the same. And it simplifies down to 56 over 65. And now here's our last problem. 10/12 minus 5/6. There's first the ECD procedure and then LCD. For the LCD procedure is we make a whole fraction out of each denominator. So that's 6 over 6 and then 12 over 12. Next, we multiply each of these whole fractions to the other fraction, or to the other side. So that would be 6 over 6 multiplied by 10 over 12 minus 5 over 6 times 12 over 12. We simplify the expression, which will become 60 over 72 minus 5 times 12 is 60. 60 over 72. Wait, you might say. These are the exact same fractions. So if I subtract it, it's going to be 0. And that is our fraction, 0. Or maybe 0 over 72. So that's LCD. Now let's try LCD. In LCD, we make a table. 12 and 6. There you go. 12, 24, 36, and then 48. In 6, we have 12. Over here, we already have a 12. So on this side, we don't have to change anything because we multiplied a 1 to get from 12 to 12. But over here, we do have to change something. We multiplied a 2 to get from 6 to 12. So over here, we can leave the 10/12 the same. And we have to change the 5/6. We multiply both the numerator and denominator by 2. That would be 5 times 2 over 6 times 2. And then we simplify. It's equal to 10/12 minus 10/12. 10/12 minus 10/12 is equal to 0, or 0/12. But after looking at these two procedures, you might also have noticed one more thing, one other way to solve this problem. Over here, you can notice that 10/12 can be simplified into 5/6. If this is turned into 5/6, we can keep the second 5/6 the same. And there you go. We have 5/6 minus 5/6 without even using any of these procedures. We could just solve it by simplifying the fraction. 5/6 minus 5/6 is equal to 0/6, which is equal to 0. Now, thank you for watching 3 Inquisitive Kids. And from this video, which procedure did you like learning the best? Which one do you think is the most efficient? Tell us in the comments down below.